Hello, everyone, and thank you for joining us on this exciting collection care and conservation laboratory tour. So my name is Megan Warwick. I'm going to be the moderator for this webinar. And I just wanted to start by saying, although we all meet on different parts of the country, I would like to acknowledge the Gadigal people, the traditional custodians of the land the museum is on, and pay my respects to elders past and present. So today we are delighted to have the Manager of Collection Care and Conservation, Heather Bleechmore, and Senior Conservator Sheldon Teare to join us for this special online event. Heather and Sheldon will take us through the recently opened Collection Care and Conservation Lab and take us through their current projects, how they preserve and treat the AM's vast collections, from archaeological and cultural objects, rare books and archives, to our biology and geology collections. So just a couple of housekeeping things first. The webinar is being recorded and it will be available to share on the Australian Museum website at a later time. At the end of this presentation, there will be a Q&A session. So please use the Q&A function to ask questions at the later part of this session. So I wanted to provide a very warm welcome to our donors, partners, and members. We're also joined by the directors of the Australian Museum Foundation and the Australian Museum Trust. So to learn more about the current work in the Collection Care and Conservation Lab, or CC&C as we call it, I would like to introduce you to the CC&C manager, Heather Bleechmore. Welcome, Heather. So
Hello.
Heather has worked at the Australian Museum for over 17 years and was recently appointed manager of CC&C. The CC&C are responsible for many aspects of the collection preservation and care, including pest management, environmental controls, objects and specimen treatment programs, exhibitions, loans, and collection storage and logistics. So Heather has extensive experience in cultural object conservation and collection care. She has gained expert knowledge in low oxygen or anoxic and freezing treatments, and she studied pigment analysis and pest mitigation strategies, and she's even dated the odd Egyptian mummy. So welcome, Heather.
Thank you, Megan, and hello everyone. I'm very happy that you could all join us today. As Megan mentioned, I'm the manager of the Collection Care and Conservation Lab, or CC&C as we'll refer to during the talk, at the AM. And today, along with Sheldon Teare, our Senior Conservator for Natural Science, we're going to take you on a journey through our new lab. And along the way, we'll give you a sneak peek at some of the projects that we've been working on, including the Egyptian cartonnage masks and the Diprotodon jaw excavation. As Megan mentioned, I have worked on some of the museum's iconic Egyptian collection items, and you'll see some of those pop up through the slides. But first, I wanted to give you an overview of what we're talking about when we talk museum conservation. Conservators are material scientists and often have a chemistry or material science background. The knowledge of materials and how they interact with one another and the environment that they're in enables us to make good treatment decisions and to minimise further deterioration. Collection conservation programs aim to minimise risks to the collection to ensure specimens and objects are stored and displayed to a high standard of care and are preserved for the future. Conservation is a small but quite specialised field in Australia that covers paper, paintings, metals, objects, frame conservation, glass, and archaeological conservation, just to name a few. It's interesting talking to people about what you do for a job. Some people know about conservation, but other people's, it's something that they've never really heard of before. And I do remember coming out of university very proud of my degree and proud of the fact that I was coming to the museum to work, and then finding out I was having to explain that I didn't do forest conservation, that I actually looked after museum objects. You may have noticed that we are called Collection Care and Conservation, and this is because there are two main streams in which we operate. Collection Care, which is more of a holistic program that focuses on identifying the risks and taking preventative steps to minimise those risks to a whole collection. Conservation refers to how we treat individual objects and specimens to stabilise or improve their condition. Collection care programs are often applied to the collection as a whole, and the main programs you can see they're listed on the slide on the right. You might be aware that the Australian Museum has 21.9 million specimens and objects in its collection, and that's a lot to look after. So it makes sense that storing and housing these collections safely is one of our biggest programs. Housing collections, from the boxes that they may be stored in to the collection store itself, plays a major role in preventing deterioration. And below in this slide, you can see some of the different approaches taken to a vast range of specimens, and you'll get to see a little bit more about this as Sheldon presents his talk. As I mentioned, identifying risks before in the previous slide, risk assessments and mitigation strategies are a big part of our role when we enter gallery or collection stores to conduct an assessment. And we are often looking for risks, and these are things like insect attack, unstable environments, light damage, and evidence of physical damage. You might be interested to know that attack from insect pests is the single biggest threat to museum collections. Insects are highly attracted to feathers, wood, plant materials, skin, fur, pretty much all the good stuff that's in natural science collections. The 4 images on the left of this slide give you some examples of what we can find in terms of insect attacks in the collections. There's holes in the side of the small lizard. There are entry and exit holes from beetles. We have insect casings, which are found throughout the woolen fringe on a mat. There are a partially destroyed entomology specimens in a drawer. And probably something that isn't that obviously thought of is the packaging that supplies and equipment that get brought into the museum can actually harbour a lot of pests. The image of the cardboard box on the screen shows a roll of masking tape, and all the little black dots on there are actually cigarette beetle. In the upper right corner is an image that shows some of the dust preparation work undertaken during Project Discover, where many of the showcases throughout the AM were covered in plastic in preparation for a construction site. And the last image on the bottom right corner is a recent collection salvage operation that we had to carry out due to a flood. Understanding the likelihood and the impact of the risk to a collection and collection items helps us define the mitigation strategies and in turn what our response to be. I actually just remembered I forgot to mention there's Sheldon there in the middle working on the elk specimen, which is in the long gallery. This slide is an attempt to summarise the approach to conserving a collection item from the huge range of materials held in the museum's collection. When an object or specimen comes into the lab for treatment, conservators spend a lot of time just looking at it. This might seem a bit strange, but it is necessary to observe what you have in front of you, and in a way you kind of need to deconstruct it to be able to put it back together again and find out what's happening with those materials. Is it cellulose, keratin, bone, ceramic, stone, glass? Is it pigmented or oiled or coated? Does it have a decoration or is it incised? And that's really just dealing with the dry collections. And we also have a vast wet collection here, which is full of strange creatures in jars of ethanol and formalin. Breaking down what we see in front of us into the materials that compose an object or specimens informs the choices that we make if it is necessary to introduce an adhesive, a consolidant, or a protective coating. In most cases, we'll consider the need to intervene at all, rather adhering to more of a minimum intervention approach. Hopefully the images in the slide can capture the range of materials that can be in the lab on a daily basis and give an idea of the documentation required. Essentially, conservators are working to understand these materials in order to preserve them for future generations. I'll finish this segment of the talk by looking at some of the analytical techniques we employ to help us observe and document collection items. As I mentioned, we spend a lot of time looking at things, and of course we're using visible light to do that. We also use magnifiers and microscopes, but there are other techniques that utilise other types of light on the spectrum. These utilise the wavelengths on either side of the visible light range that include the longer wavelengths of infrared, to the shorter wavelengths of X-rays. And shown here are some examples of what we've taken in terms of X-rays that help us find out what's going on inside objects. A top left image may look a little bit macabre, and it is from our Egyptian collection, and it is a mummified hand that I worked on some time ago. You can see quite clearly from the X-ray that the hand is vertical, and there is a steel rod inserted inside with a wooden base. And the reason why we had that in the lab was that we needed to remove the old mounting system, and the X-ray helped us determine how far the steel rod went inside the hand so that we could work out the best method for removing it. On the next to that is one of my favourite X-rays, which is this crazy image of the inside of a bird, of a taxidermy bird specimen. And you might be able to see from that X-ray that one of the long steel rods is actually piercing through the chest, and it was making it quite dangerous to handle. But before we could actually cut it off, we needed to check that if we did that, the whole specimen wasn't going to fall apart. And the last two images down the bottom are of an object that's on display in the Long Gallery. And this object is a known fake Egyptian mummified cat. And fakes were quite common throughout the Victorian time. And in order to make sure that we had evidence of that, the mummified cat was X-rayed, and you can see very clearly there's no skeleton inside there, but just steel rods and some pretty solid packing materials. So obviously we're as eager as you are to get back to business as usual, which for us, that means in order to be able to talk to you from the lab without our masks on, we could only have one person in the space at a time. So you're about to go on a selfie tour, quite possibly a world first, in the CC&C lab, which was recorded earlier. And then we'll join Sheldon in the space for a chat about natural science conservation. So here we are entering the doors into the Collection Care and Conservation Lab. Our offices are there on the left. There's not really that much interesting to see there. So heading in through the main doors, we have the main lab, and when objects are brought in to the lab, they need a safe place to be stored while they're being worked on. And this is our objects cabinet, which is currently housing several specimens that have been selected from the minerals collection. And these are being brought into the lab for processing for the new minerals gallery, which is opening next year. We'll be looking at processing almost 1,000 specimens through the lab, so that is a very big job. And this is an overview of the main working lab within the museum. You can see one of the Egyptian cartonnage mugs out there on the left. And heading forward, you get an idea of some of the workstation setups throughout the lab. In front of us now is our paper conservators workstation. There are a few documents out there which are from our archives collection of early correspondence. And walking up towards this table, which is a new piece of equipment for us. It's a light table which helps us define areas of weakness in 2D objects, paper and tarpa cloth. And when we swing around to the right, we come across our box making station, which is where we make a lot of our housing for individual specimens using archival materials. We have a range of cardboards and foams and various tools to help us cut and make the boxes. This is towards the front of the lab, and on the left here is a painting that's been brought into the lab for a condition assessment, the Diprotodon jaw, which we'll get to a little bit later with Sheldon, so don't take too much of a sneak peek at that. And then this is our analytical area with some of that equipment that was up on the screen before, where we have microscopes, the FTIR, and the portable XRF machine. We also have up against the wall some of our pigments that we use and some of our dry chemical storage. Behind that area is our new wet lab. where we do all our solvent work. We have an extraction arm for use, which is hovering over that table there, and a fume cupboard in the back for a lot of our solvents work. And on the table here, you can see an example of some of the testing that we do. This is an adhesive testing grid for various concentrations of adhesive film for a consolidation of treatment. The other equipment that you can see in the lab are fairly domestic. There's a fridge, there's a dishwasher, washing machine, microwave. I think we've also just zipped past some herpetology specimens in a wet box. And over to the left is our dangerous goods cabinet where we store all our solvents. And coming up to the lab, this is what you see in the education corridor and looking into the lab. These are our on-view windows, and this is giving the public a bit of a window into the operation of a lab, of a conservation lab. So on any day, you can see a variety of conservators in there working on different materials. In the window there is the Diprotodon jaw that Sheldon's working on. So it's a real insight into how a functioning lab just works on a daily basis. So one of the things I touched on briefly was the Egyptian cartonnage masks, and now we'll get to look at them a little bit closer. The conservation project of 3 cartonnage masks and body coverings has been funded by the Australian Museum Foundation and is a project that I'm quite excited about, having worked on quite a bit of the Egyptian collection before. The masks will feature in the new Egyptian exhibition, which is scheduled for opening in 2024. Let's have a look. So the 3 masks on the screen were proposed for conservation and research, firstly because of the condition that 2 of them are in, and secondly to confirm the date estimations and examine them in a little bit more detail to prepare them for display. It's estimated that the masks are around 2,500 years old, and the project will aim to confirm this through radiocarbon dating. Cartonnage masks were used in ancient Egypt as part of the burial practices as a funerary mask to cover the linen-wrapped mummy. The masks are made of cartonnage, which is a material of waste papyrus or linen and resin soaked in plaster. You can see we have our work cut out for us with the very fragile and brittle nature of the cartonnage, particularly with the mask on the right. And you can see a more detailed photograph there of some of the cracking and lifting of the cartonnage. But one of the more interesting results of the initial examination for me is less about what is on the front of the masks and more about what is behind or underneath. And I'm just going to show you a very special peek of what the underneath of one of these masks look like. So what you can see on your screen is the upside down mask lying on some supportive cushions. The round circle at the back is the head, and the bit towards the forefront is the front of the mask. This is the inside of one of the more fragile masks, and there's a lot of information here about the method of manufacture, previous repairs, and attempts to stabilise the heavily cracked linen and plaster. And so sometimes it's not what's on the top of an object that's really interesting, but it's actually what's underneath that holds the biggest information, and sometimes even more mystery. All of what we can see here makes up the unique history of this object, and it is therefore necessary for us to document that thoroughly in condition reports and photographs. The project conservator working on these masks will be posting blogs about the treatment process, so have a look at our CC&C webpage for the link in the future. And now it's time for a journey into natural science conservation with Sheldon Teare. Sheldon is our Senior Conservator of Natural Sciences, and he is responsible for providing expert advice and conservation treatments across the natural science collections. Sheldon's current research is in specimen preparation and in particular composting methods for skeletal preparation and fluid preservation techniques. Sheldon will be joining us live from the lab, but first he'll talk about the general techniques of natural science conservation and preservation, including some fun stuff. But before we'll cross to the lab, welcome Sheldon, good to see you.
Hi, Heather. Thanks. So hello, everyone. I'm Sheldon, and as Heather mentioned, I'm the Senior Conservator for Natural Sciences here at the museum. And so I think I have the best job ever. I get to work across all the science collections held at the museum, and I get to see all of these incredible specimens. I work with the collection staff to ensure that specimens are preserved and cared for, so that current and future public and researchers have access to them. My work day can be vastly different from one day to the next, jumping from working on things like minerals to birds to insects, so it really keeps me on my toes. I'm going to share with you some of the images of my team and my work, but please bear with me with this talk. I'm used to giving these kind of talks in front of the specimens with people pointing at lots of things, so it's a little bit strange doing it remotely. So first thing, I must talk about collection housing, or as I would like to have it called, collection infrastructure. Collection housing is so important when it comes to preserving over 20 million specimens. A high quality enclosure, or the housing, does so much to help preserve that object. It may seem just a box, but we put a lot of effort and time into making quite unique enclosures for our specimens. So we will have a look at some of these examples. So in this slide, you can see a crocodile skull. So it's quite heavy. You'd think it would be quite robust, but the plates within the skull can actually be quite loose. You might see there's quite a number of teeth missing. So we've got to make sure that those are secured and can't get lost. So that's why we've positioned it as we have. And you'll notice that even the lower jaws we've isolated from each other so they don't rub together. And we're using high density foams here with smoother foams just to make sure everything is safe and secure. In this image, you can see a little freeze-dried lizard, and this specimen's been recessed into a block of foam. The little red square I put in there is just to highlight, it's quite hard to see white on white there, but we actually have a smoother foam that isolates the rough foam from the specimen, so it doesn't abrade the skin. In this image, you can see an old example of housing on one side, on the left. So we can see the bones are kind of a bit jumbled together there. With the red vinyl material, we weren't too happy about its archival qualities, so we've moved it into the box on the right. In the new housing, we've separated out the bones, we've kept the skull plates in one area, and on consultation with the researchers, we found that they often just want to look at the teeth. That's quite useful for them. So by positioning the skull and the jaws upright like that, we hope that maybe some of the researchers won't even have to handle the specimens at all, but can still do their research. This is a semi-articulated snake skeleton. So there's a cord running through all the vertebra bones there, and it's quite unwieldy and quite difficult to handle. So we've blocked it out in its box to keep it in order and used cotton ties to hold it in place. And you can see all the rib bones are in little trays off to the side. So mineral specimens are quite a challenge. They are often quite heavy, but very fragile. So the crystals forming on the mineral specimen can be damaged very easily. So we have to be very careful where we put any of the blocking to corral the specimen or hold it in place. And you might be able to see written all over the box there, I put instructions pointing to certain areas, suggesting where people pick it up, and how to fit it into that arrangement of foam blocks so that it's safe. So enough about storage. We'll go on to treatment, and this is, I guess, the stuff that conservators really love to do. It's the fun stuff. So this is our Marlin. This is currently hanging up in the Wild Planet Gallery, and it's well over 160 years old. So in this image, you can probably see the old grey paint and the underlying skin. So the taxidermists, when they made the specimen, they covered it with a fairly thick layer of that grey paint. The problem being the skin is flexible and moves around a little bit over time, and the paint layer can't. So over time, the paint has flaked away. And in that red box that I've put there, you might be able to make out that kind of cracking pattern of the paint layer. So that section is pretty much ready to fall away. And so we had to consolidate all the paint back onto the skin by feeding glue with little brushes under every single crack, every line, over a specimen that is over 3 meters long. So it took quite a long time. Once all the paint has been secured in place, we need to infill the losses, and we don't cover any of the original paint. We want all the original material to still be there and still be visible. So we had to cut and shape all our Japanese tissue paper infills around the original grey paint. So you can kind of see how complex those shapes and how complex that process would be. Once the infill material is dry, we in-paint, but we're only in-painting the material that we added. We do not paint the original paint. And the reason why we do this in-painting is so that when visitors come in to see the object, it looks whole and it's readable as a marlin on the wall. If it had that white infill material there, it would be quite distracting. So sticking with the marlin, this is its tail. There was clearly something structural going on, some damage, and we weren't quite sure what was going on. So the whole tail was drooping, and we suspected something had gone awry with the internal armature. So unfortunately, we had to remove some of that original stuffing that you can see in the middle of that image. The red square is just showing you a piece of skin that is just about to kind of give way. So in this image, working with our preparatory team, we were able to figure out what was going on. We found the internal metal rod and the original wooden armature, which is right at the back of that image. They had kind of come apart, dislocated a bit, and so we're no longer providing the support for the large tail fins. So working with our prep team, they were able to secure all those elements together. We were able to get the tail back into alignment, and this is an image of us doing an infill, so replacing all that material that we had to remove, and we use a Japanese tissue pulp just with starch paste. So the reason why we choose to use these materials is because they actually dry quite hard and provide quite good support, but they're fully reversible. So for, if there's a problem in the future, this material is very easy to remove, and you might see the bit of skin at the bottom has been realigned and put back in place. So this is actually the nose of an Aardvark specimen. This specimen is very, very old. It might even hold the record of being our oldest taxidermy specimen. But you will notice the nose is quite badly damaged, and the white areas are actually hard plaster that the taxidermist used. So unfortunately, over time, the skin shrinks and the plaster can't. So the shrinking skin has split along areas of weakness, and we've lost some skin at the front of the nose there where it's actually pushed back onto the metal armature. So my colleague was able to do quite an amazing repair here by realigning all those elements, using Japanese tissue as an infill material, and in painting with watercolors to give the poor Aardvark its nose back. This is an image of a smaller fish specimen, and this is just an example of some of the decisions we do in conservation. So this is the back of the specimen. This is the side of the specimen that would be against the wall, so the public would not see this. You might make out the incision running along the bottom of the fish there. That's where the taxidermists have cut the fish to mount it. But on the tail tips, you'll probably notice some white little tabs of color there. So the tail tips were very fragile and distorted and about to kind of detach. So we've decided to reinforce them from the back, but instead of in painting them, we've left them unpainted, which will draw attention as people handle it in the future that there's an area of weakness here, and just to be alert. The images on your screen now, the red box is just a highlight of that. The modern field repair that I've done. And the blue box is an older repair where someone has gone to the trouble of in-painting. So ears are quite a weak point on taxidermy. They don't have a lot of structural strength. Sometimes a taxidermist can get some kind of supporting material up into the ear, either a flexible piece of metal, or a bit more modern, they use some sculpted plastic or little bits of plastic film. But sometimes there's no way of getting any support in there. So ears do tend to get distorted and damaged. So this image is of a fox specimen, and we're just doing some reshaping where we're able to use blotting paper with water on it, and covering that with some flexible plastic film to hold the water where we want it. And we leave it for a couple of hours to soften, and then we can reshape the whole ear. This is an eye, which is a type of lemur, and you can see that ear is in a pretty bad shape. This is a very, very old specimen as well. And this is the ear after we were able to do a treatment like the fox ear and get it back into a shape that's much more appropriate. So ears are a bit of a theme here, but this is a red kangaroo, and his ear has completely detached. So this is an example of where I believe the metal that's used to actually give the ear the shape has been too heavy, and it's actually torn the ear away from the underlying fiberglass mannequin, which you might see in the middle of that red box. And in the red box, you can probably see the sort of rough edges of the skin where the ear is torn away. So I was able to build up the losses there, and eventually get the ear to sit back where I wanted it, realign it, and in that red box on your screen, there's just, you might make out that lighter line, that's just some Japanese tissue infilling material, and that would be painted once it's dried to blend in with the fur. So this is a sloth bear, which is a small shaggy-haired bear, very old specimen, and we believe it suffered quite a lot of damage as it was removed from a very old diorama. So on both of its front paws, the claws, some of its claws were lost. So that's 2 claws missing on this paw. And so using the claws that are still there, I was able to make a template and carve new ones using balsa wood to reintegrate with the specimen. So in this image, the red boxes show the claws that I've made and put back onto the specimen. So hopefully they are convincing enough that if you are up in Wild Planet, you might have trouble guessing which ones are real and which ones are fake, but on very close inspection, they should be very easily discernible. So there's just a little bit of a gore warning here. As Heather's mentioned, I am currently investigating composting as a skeletal preparation technique. So if you're still having your lunch or something, I don't know, you might want to look away. It's not too bad. So this is a whale skull, and so it's coming out of the compost. It went in with no preparation, no flesh was removed from this little whale skull. It went in whole to the compost, and in about 6 weeks, all the bugs and microbes did all the hard work for us. So usually when preparators are doing a skeleton, there's a lot of resources required to get it down to the bone, either in time of cutting away the flesh themselves, or a lot of water is used in maceration, and even solvents are sometimes used to get the bones clean. We've found that composting is doing all that work and using none of the resources. So we're very keen to do more specimen preparations in this manner. And this is a small, sorry, trying to move to the next slide. Thanks. This is a small dolphin, and it's also just, you can see how easy it is to move the very lightweight compost material aside, so no damage to the specimen, and it produces these beautiful skeletons for us. So the general idea, a lot of people think conservation is very genteel, always working in a lab, it's beautiful objects, and thankfully that is the case for me sometimes, but other times it's a bit weird, it's a bit bizarre. I find myself in some pretty strange situations. So here I am cleaning the tongue of a bear, a little black bear. So that might seem a little bit ridiculous that I'm cleaning the tongue with a cotton swab. However, this is an old specimen, and we have no records on the materials and techniques used to model that interior mouth. So we don't know if the pigments are going to be soluble, if anything could dissolve. So we have to be very careful, go very slowly, and make sure nothing is taken away in our work. And then sometimes I just find myself in really bizarre positions. But here I am moving a cassowary around to try and get some photos of it. But luckily, or unluckily for me, my colleagues always have their smartphones ready to snap a picture of me in highly compromising positions. So I'm going to move straight on because I'm just wary of time. And we're going to just talk about the Diprotodon fossil that Heather mentioned in her talk, and the work I'm getting started on in this. So the fossilized skull and vertebra of the Diprotodon was discovered by local landowners in Tambar Springs, which is in the northwest of New South Wales. The fossil is affectionately named Darren, and he was excavated by a team of researchers from the University of New South Wales. So measuring up to 3 meters long and 2 meters tall at the shoulder and weighing around 2 to 3 tons, the Diprotodon octatum is the largest known marsupial specimen to ever live. It's estimated to have gone extinct around 40,000 years ago, and its closest living relatives are the koalas and wombats. So Darren is a rare find, given that his upper and lower jaws are still in place and the neck vertebrae are still attached. So based on the size of the bones, he's believed to be a young animal. That's the specimen when it was briefly on display when it was returned to the museum. So after recording and preparing the exposed Diprotodon bones, the team from the University of New South Wales dug a deep trench around a large area to lift the bones as a block. Here you can see the paleontologists at work digging that trench. So plaster bandages are then applied over the bones as a protective layer, and then a jacket of plaster is put over the entire block of soil and bones. This image shows the block of earth containing the bones covered in the plaster to form that jacket, and the wood is being laid across the top and set into the plaster to help lift it. So once the soil underneath the plaster covering the mound is cut through, it can be lifted out of the ground. Note that the whole specimen and soil is flipped over so that the surface initially uncovered is now at the bottom of the jacket. It took 5 people to carry this enormous fossil block to the vehicle. So this incredible fossil was partially prepared at the University of New South Wales and is now part of the Australian Museum Paleontology collection. The specimen has been moved up into our newly refurbished conservation labs, and that's how it is sitting on my workbench. The surface of the bones have been exposed, but full excavation is still required. You can clearly see the neck bones, the huge lower jaw, parts of the skull, and the large teeth. Oh, sorry, I'll just go back. Unfortunately, the site where the fossil sat was driven over before Darren was found, so there is some damage to the bones. The extent of this damage is unknown, so we have to be very careful when removing the surrounding soil, as there could be broken pieces amongst the soil that we need to keep. The back of the skull appears to be extensively damaged and caved in, so we will most likely resort to sieving the soil matrix as we work in that area to recover the bone fragments. So on this slide is some of the preparation work that we undertake before we continue the excavation. Our paleo team asks that we put a grid over the specimen, and this will help locate and identify the pieces as they are uncovered. As we uncover the sections of the bone, we'll be strengthening them or consolidating them. We carefully apply a high quality archival grade glue into the bones. So this adhesive is very thin and can flow inside the bones through the cracks and add structure and strength as it dries. So you might be familiar with spongy or cancellous bone, which is like a honeycomb structure inside bones. The role of the adhesive consolidation is clearly demonstrated here, where it fills those honeycomb structures to support the bone. Imagine the open spaces in this image of bone being filled with an adhesive. Once that dries, that part of the bone would be much more solid and stronger. This allows the researchers to handle bones and study them without breaking them or having them cave in. We have to apply this adhesive in multiple layers to build it up over time, and this can slow down the rate of our excavations. Here you might be able to see some of those spongy bone parts in the vertebra that I'm uncovering. So once I brush away the soil, I will feed the consolidating adhesive directly into those exposed sections. So we have made a start on the excavation, but had to step away from on-site work for the time being. I have begun uncovering the vertebra bones as these seem the best preserved and a good place to start. I've been using wooden hand tools to break the soil surrounding the bones and then brush it away. So some of the brushes I use are quite stiff to help break up the soil, but others are much softer for use on the bone surface so that I don't actually damage any of those fragile exposed areas. As each section of bone is uncovered and freed from the soil, we'll clean it up if it needs it, apply a label so that our collection staff can store it and provide access for future research. So here in this slide, you can see the specimen positioned in front of the public viewing windows. So yes, you can actually visit the museum and see us working on this specimen. when we're open, of course. And now, hopefully, through the magic of internet and multiple camera angles going, I'm going to shift over to the Diprotodon so you can actually see it, and we'll be taking some Q&A.
That looks wonderful. Thank you so much, Sheldon, and thank you, Heather. Great to see Sheldon just getting set up there with the Diprotodon. So yes, thank you, Heather and Sheldon, for taking us behind the scenes in the CC&C lab and for sharing with us your areas of expertise, the projects you're currently working on, and the analytical techniques. It's fascinating to see, and so great to see Darren, the Diprotodon, there with Sheldon now. So we can now open up the conversation for some Q&A, so please use that function. But I think I'll just get started by asking Sheldon a little bit more about the Diprotodon. So Sheldon, you mentioned that the Diprotodon was the largest, most marsupial known. It's got quite an oversized skull as well, with quite a few air spaces. So could you maybe, whilst we're seeing you with the camera there, maybe outline with your hands the skull area, just to make it obvious for everyone looking in, and also let us know.
So the lower,
keep
lower
going.
jaw would be down here. I don't know if you can make out the large tooth over here, and the skull, as I mentioned, has had a lot of damage. So we're thinking throughout this area we're going to find a lot of caved-in sections, but it's got quite a flat skull, so the impressive lower jaw, and you might be able to work out the sort of bones around the side of the face.
Yeah, thank you so much. It's fascinating to see this in live action, and you went into the excavation techniques and the whole process, which was quite intricate. Just wondering, what has been the biggest challenge working on the Diprotodon from your point of view?
Well, yeah, I guess it's often a challenge for me, but it tends to be the size of the specimens that end up on my sort of work schedule. The large taxidermy, the large skeletons, they tend to be old and in not the best condition, and then it becomes quite a logistical challenge even to get access to them and work with them. So this is a very heavy slab, and it took quite a lot of wrangling even just to get it up into the lab here. So just maneuvering it around to get access. We want to keep it in the window where people can see us working on it. But actually, so far, the biggest challenge has just been making sure I don't make our brand new lab quite dirty with all the mud coming out of it.
Always a good consideration. I'm sure Heather's very happy with that as well. Well, fantastic. We do have some questions that have come through, so I think I'll just jump in. And the first question is for you both. So I might start with Heather. So they said, "Hi, Heather and Sheldon. So fantastic to see inside this very important part of the museum. So how many staff do you have working in the CC&C department? And maybe if you go into your teams at the moment, that would be great."
Well, there's currently 9 working, including me. We have a natural science conservation team, which Sheldon heads up, and there's 2 conservators working with him. We also have a conservator working for our collection enhancement project. We have currently 2 cultural collections conservators. We have a paper conservator, and we also have someone who's coordinating our very busy collection care program, which looks after some of those programs I had up on the slide earlier.
Okay, great. Thank you. And Sheldon, roughly how many people would you say you work with on a day-to-day basis, outside of the COVID restrictions, obviously?
Well, yeah, again, that's a really lovely part of my job, because I do get to work across 10 natural science collections, and there's at least 2 to 3 people in each one of those teams. So I get to ask all the annoying questions about the specimens, but I also get to work with our exhibitions teams and our taxidermists quite a lot. We have a close working relationship just to make sure methods and materials and techniques are kind of moving with the times in taxidermy.
That's fantastic. Thank you so much. And that really leads into the next question that's come through. We've got a question from Matt just wondering if there are any developments in conservation technology that are in the pipeline that you'd like to see being used in the future. And I guess that kind of comes into, in your areas of expertise, what do you see kind of becoming bigger and kind of the technology that we could start using more often?
So I can quickly jump in there. I guess, in taxidermy, there's a lot of traditional materials and techniques still being used, and a lot of those materials aren't exactly archival. But there has been a bit of a shift in some of the leading taxidermists in Australia to look at more archival materials used in their mannequins, as well as the use of like 3D printing and 3D scanning, which means the mounts that the skin put on are such better quality, and the results are just these incredible mounts that we see at the end. So yeah, I'm trying to work more with the production and specimen preparation so that we don't see the old materials that don't hold up so well finding their way into our modern collections.
And Heather,
I think I'll
question.
just add to that. I'll just add to that. I think there's a lot of techniques and sort of technology that's been used throughout conservation that hasn't necessarily changed so much, but perhaps the technology has just gotten a lot better. Sustainable practices are probably one of the areas, sustainable materials and how we use our materials, the ability for us to be able to reuse materials but still keep that archival nature is something that we're continuing to explore.
Yes, thank you so much. I know there's a lot of policies and procedures in place to be as sustainable as possible, and obviously this is a big area that CC&C can be part of too, and I know that you are a big part of it. So, and thank you as well, Sheldon, for your taxidermy. I have seen some fantastic images on Twitter of the not so well done taxidermied images, which could be quite funny. And it's actually really linked. We've got a question here, and you did already touch on this about how taxidermy techniques have developed to allow for skin shrinkage. And also, is plaster still used? I know that you work with our taxidermy department, so did you have anything further to add on that point?
Yeah, I mean, the shrinkage is still a bit of a problem because you are working with it's not overly exact. You don't know how much a skin might shrink over time. So they do allow for that. There are special glues that the taxidermists use that allow a little bit of movement. But again, this is where conservation and taxidermy professions, if we get together, there might be better synergies there because we've got conservation has developed glues that remain tacky for textiles conservation, and if we, start applying those into securing down skin, maybe we'd be able to see less damage from shrinkage and things like that. But
Yeah. Well, thank you so much. I also wanted to just ask to both of you, because it's such an interesting area. And as you said, you've got very interesting jobs and you do such a range of things. So I wanted to ask a bit about how you got into your current role, the kinds of things that you studied. So how do you become a conservator?
So I studied at the University of Canberra, which still they offer a course now. It's not quite the same course that I did, but most conservators are going through the University of Melbourne to do a master's at the moment. But really, there's a materials science background, and some people come at conservation from just sort of different disciplines, even through the fine arts and doing fine arts degree and then building on that, and coming around to the material science, understanding how materials work with one another. So, there's always a range of sort of entry points into conservation.
yeah, I think so. I did the Melbourne master's course quite a long time ago now, and that's one of the nice things about conservation is people do come to it from varied backgrounds. So everyone's bringing something different to the table. I'm quite rare, I think, in conservation in that I don't have a pure fine arts background. I can't paint to save my life, but a lot of people do come from visual arts, but then other people come in from science, things like that. So, a varied team is great because then you've got skills that you can draw on, and you're always learning throughout the profession as well. If you are conservative and you're not learning something new, there's not something you're not doing something right there, I think.
I think that's probably a really important point to pick up on, is how much we actually learn from other people within the museum as well. So much about the work that we do is about consultation with collection managers, with prep staff, with exhibitions, with facilities, and even security about how we can best look after the collection. And it's not just up to us, it's up to a whole range of professionals working at the museum.
Yeah, fantastic point to finish on now, because that takes us to time. But I know you're an extremely multidisciplinary team and so integral to everything we do at the Australian Museum. So thank you so much for your time, both to Heather and to Sheldon, for your insights and for showing us your fantastic new lab. So I also wanted to thank all of the attendees for tuning in. And also to let everyone know that I know we couldn't get to everyone's questions today, so please feel free to email them through to our development team or to the AMRI team, and we'd be more than happy to answer your questions. And this webinar is being recorded. It will be uploaded to our AM website under our exclusive events, so you can feel free to share this with all your family or friends, or just take another look at it yourself. And again, thank you, Heather and Sheldon, and take care, everyone. We look forward to seeing you at the Australian Museum very soon. Actually, it's very exciting. So thank you, everyone.
Thank you.